I've never been any part of that group like that. But these were 5 guys who saw an opportunity in ballooning, and they were enthusiastic about it. And they realized, we're not going to make a lot of money in this. What we need to do is find something with a government contract, perhaps, that we could turn this into something. So they were able to secure a government contract for weather balloons. And that sort of that gave them a little bit of revenue to fuel everything else. And that diversified. And once that contract came up, they realized this isn't really going anywhere. So then they started getting into things like paper. Has anybody here ever worked with the Porter cable or Delta tool? Woodworking tools. So we used to own Porter cable and Delta. DeFilbus with the pressure washers used to be a Pentair company. Federal cartridge, so ammunition, owned an interest in that for a while. But as time went, in 1995, Pentair bought Fleck Control. So that's that plant in Brookfield that I just showed you. And I think the idea was when the folks came walking through, it was a little privately owned company. And they looked around and said, there's kind of a lot of waste going on here. It's not really efficient. They're real profitable. They're doing a great job. It's the #1 brand in the industry as far as perception and everything. But we could really streamline this. We could really make this. We could tighten this up and really turn it into something. So Pentair bought Fleck Controls in 1995. Fleck Controls makes valves, or made multi-port valves like this one. So this is one of the newest family of residential valves right here. So we'll talk about this later on. But we make multi-port water treatment valves in Brookfield, Wisconsin. Bought it in 1995. And was so, kind of turned it around. We now manufacture every single valve that we make, not just Fleck, but Autotrol valves are now made in that same plant. So a lot of it was streamlined, cleaned up. We do all of our own machining. So we bring in brass valve castings. We do all of our own machining in-house. That's all done in-house. And they realized, wow, this water thing, it's not going away. Water quality, water treatment, the concerns for where freshwater supplies are coming from, it's not going away. Maybe we need to focus in on this whole water thing. And then over the next 10 years or so, they expanded from those valves and then began to invest in pressure vessels and in filtration, bought structural fibers, bought Park International for pressure vessels, bought Plymouth Products and Amatec. For any of you guys golfers? All right, so if you go on a golf course, it's not unusual. So the little irrigation, the caps that go over the valves for the irrigation systems, if you look on those caps, it's not, you'll see like Armor by Amatec. So that company in Sheboygan, Wisconsin was the ones that were injection molding those irrigation covers. So the biggest part of their business was that part, but they also made filter cartridges there. And the part that Pentair wanted was the filter cartridges part. So they bought that from Amatec and then branded it Pentec. So now we were able to cover all the bases. We could do from the start, simple filtration, all the way to bigger stuff. Residential, commercial, water treatment, valves, tanks, and the whole kit and caboodle. And then on the other side too with water, we have a large pump company. So it's kind of, I always tell people, from the moment that you find the water, that you move the water, store it, treat it, and supply it, Pentair, and if you're going to be using it in your pool in the back for recreational use, whether it's utility, recreational, whatever happens to be, or consuming the water, we as a company are able to provide products for all of those different things. And that's pretty cool. And I've gotten the chance in the 26 years to see all that happen. So let's start talking about water, all right? Let's look at this home here and start to consider kind of where water comes from. First thing I want to point towards is kind of the two main sources of where water is going to come from. Primarily, if you look around the United States and really around the world, where major cities are located is typically on an area where you've got an easily accessible freshwater supply. So you'll find a lot of the big cities are on rivers, on lakes. I'm from Wisconsin, Great Lakes area. Great Lakes are one of the largest freshwater reservoir systems in the world. So it's a big deal to be able to have that as a resource right in the middle of our country. And all the cities that are around the Great Lakes are sourcing their fresh water straight from the lake. which is kind of curious too when you think that we're also pumping all of our sewage right back out into the lake. And then, you know, that kind of whole, that circulating system that happens naturally. Pump it out, it gets filtered naturally, we pump it in, we filter it, we use it, pump it back out, that kind of whole thing that's happening there. That's caused some problems over time, but we'll get into that too when we get into filtration. Some of the things to talk about when we're talking about those two different water supplies. Surface water, readily accessible, it's right there in front of you. Groundwater, in subterranean rivers and lakes, is stuff that we have to drill down and get to out of the ground. All of our water is going through a continual treatment process all around us. And I know if you've seen this before, because usually what happens here is it's the statement that, well, all the water that's been on Earth has always been here. It's always been here. It's just going through one part of this cycle or another. Where we start from, where we have all of the majority of our water on Earth is in the sea. So if you look over here on the right, and you consider all this water out here, 97% of that water is out in the sea. Okay? Now, is that consumable water? No.
Not easily.
Not easily, right? You wouldn't want to, you wouldn't want to depend on that as a source of your drinking water. So I want to give you, for your notes, I want to give you the first thing to write down. I want you to write down TDS. And I'm sure you guys probably you may have heard of this already. Does anybody know what TDS stands for?
Totally dissolved solids.
Yes. Total dissolved solids. And what that means is that, and it's important to know this, TDS is part of the water. Okay? It is part of the water. Just like when you drink chicken soup and you drink that broth, that stuff that's in there isn't like particles that are floating around in that broth. That broth is what it is. It's a soup. It's a solution. Well, TDS is part of that soup that is the water. And that's important to know, because as we go through these filtration, the methods, there's different ways and methods that we need to use in order to address some of these things. Does anybody happen to have an idea of what, so if I say total dissolved solids, and I say, and it's part of the water, does anybody happen to have an idea of what the total dissolved solids is in seawater, like in the oceans? If you were to typically in the oceans, the TDS levels are right between 30,000 to 60,000 parts per million. Now, that on its own, I say that, and that doesn't really mean a whole lot. 30,000 to 60,000 parts per million. So ppm, that stands for parts per million. So if we say we've got 6 million people in Dallas-Fort Worth metro area, so parts per million is a ratio of that 6 million. So if you take that and you consider, okay, 30,000 to 60,000, and that's parts per million, that means out of the 6 million people in the Dallas-Fort Worth area, we're going to take 50,000, so put it right in the middle, 30,000 to 60,000, take 50,000, multiply that by 6, and that's 300,000. So that means 300,000 of those people are not water, and the rest are H2O. Does that make sense? So that's what 30,000 to 60,000. So if we say 50,000 parts per million, that means 300,000 people in this metro area are not water, H2O. There's something else. Calcium, gold, uranium, nitrates, sulfates, magnesium, whatever it happens to be. That's what that TDS level is saying. Out of that million. So it's still kind of a small number when you consider it, right? 300,000 out of 6 million. So it's still the majority is water, but when you consider that, and if you were to take a handful of seawater and put it in your mouth, that 50,000 TDS still makes a big difference, doesn't it? Even if it's just a small segment of that million, it still makes a huge difference. You wouldn't be able to survive drinking that water. All right? So let's get away from seawater for now. We can come back to it and talk about how to make that pure H2O later, but let's get to where we can get to fresh water. So as we move through the hydrologic cycle, and that water that's out in the sea is evaporating and turning into vapor, when it gets into a place where it starts precipitating, it's falling back down as relatively pure H2O. So that's like distilled water. It's picked up some things in the air. You know, it's in steam form, it's in vapor form. It's picking up some of the gases and stuff that are on it. But when it precipitates, falls back down to the ground, it's pretty pure H2O. It's relatively clean water. When it gets back down to the ground, it's going to try and make its way back to the sea. Now let's think about this for a minute. So we've got relatively pure water. It falls down